I know it's come to lunchtime, so I'll try not to keep you too long. This talks basically about the AWS BuilderCards and how we use it to implement it for learning different AWS services. Cards are here, and there'll be an opportunity for somebody to win these cards. So let's get started. So who am I? I'm Bradley. I'm currently a junior software engineer at Hamilton Robson. I started with the team just over a year ago now. That's really where I learned about AWS and sort of first got to use it. During my education at Ulster University, we did use cloud technologies, but unfortunately we didn't get to use AWS. It was Azure. So it's also my first talk. It could potentially be my last talk, depending on how this goes. Hopefully not. It's in person memory. So the challenge as a junior software engineer, entering the world of AWS can be very overwhelming just to the sheer amount of the different AWS services. And it's not just newcomers. It's people coming from, it's engineers with experience, coming from other backgrounds, such as like Azure or GCP, and just how overwhelming it can be when you transition into AWS. So just to give you an insight of how many services there is, there's over 200 services within Amazon Web Services. And if I sit here telling you that I knew every single one of them services, I'll be a liar. So let me show you what I mean. So this is just like a glimpse of the vast ecosystem of the different AWS services, and this isn't even all of them. But don't worry, we're not here to memorize every single service, are we? So here we have 12 icons representing some of them 200 plus services, or do we? This is just a little social experiment. Well, most of you might recognize which one it is. One of them here doesn't belong here, and it's actually an imposter. So this exercise, it's not just about spotting the odd one out, but it's about understanding how everyone can be someone new to AWS. Because when you see all these icons, they start to look quite similar. So can anyone point out, apart from these four in the front row, which one is the imposter?
Bottom row.
Bottom row.
Red one.
Let's see if you're right. So yeah, you're correct. Most of you probably knew my Photoshop skills here. I think I actually made the icons for AWS, but this little exercise, it was just a quick exercise, just to show you how easy it can be to get lost in the sea of AWS services, especially when they all start to look similar. But spotting the fake icon is one thing. Deciphering a real AWS architecture diagram is a completely different thing. So this is just a random architecture I've grabbed off the internet. Just to give you an insight of how complex these can be, and probably seen from some of the other talks today, there's been some pretty complex architectural diagrams presented today. Now I could spend the next hour going through each component of this diagram, but I'll not do that to you. Instead, I'll keep things a bit simple and show you an architectural diagram for one of our projects at Hamilton Robson, Marvel. By the way, the Marvel Avengers are not going to come flying in here. So Marvel is a media content platform we developed at Hamilton Robson. It's for users to upload and store audio files. And as you can see, it utilizes many of the different AWS services, such as the API Gateway, Lambdas, DynamoDB, S3, and CloudFront. And these services are the building blocks of our architecture, but they're also represented in another format that we've been using to make learning and implementing these services more engaging. So I'll show you by showing you what some of these AWS BuilderCards look like. Hopefully this works. So these are what the services look like, and then it shows you the services as the cards. So for instance, we'll have the AWS Lambda, and then the Marvel architecture, it shows up here as a card, highlighting its role in the system. And this card-based approach makes it easier to visualize and piece together different components of the architecture, as well as especially helpful when designing or learning about complex systems. AWS developed these cards to merge the real-world considerations involved in cloud architecture, which I'm now going to walk you through how we've used them at Hamilton Robson to enhance our learning of different architecture. So before I get started, if you want to scan this QR code, it'll take you through to the official rules of AWS BuilderCards. Promise there's no rec rules here if you are to scan this. Just a quick scan of the rules. But here's the thing, at Hamilton Robson, we do things a bit differently. And we've come up with our own custom games that better suit our team's needs for learning AWS. I'm excited to show some of them with you. Again, before I dive into the custom games, let's first take a closer look at different type of cards that are actually included in the card deck. So there's three main cards within the builder card pile. And first of all, we have the starter cards, the builder cards, and the well-architected cards. At Hamilton Robson, we haven't really come up, in our custom games, we haven't really come up with a sort of use case for the starter cards. There is one game where we utilize them, but the main cards are the builder cards. Of course, that's all the different services. As you can see here, the EC2 on a game, it just tells you what type of service it is with compute. And then it sort of has a primary and secondary effect, which is this is more for the official rules. And another important piece of the card is the QR code and the brief description. I'll show you what happens whenever you scan that QR code in the next slide. We also have the well-architected cards, and that's what we use for our point scoring system. And these come in either 3 or 1. So have a look at whenever you scan this QR code. So as you can see, it takes us to the given services on AWS website. So say we've scanned an S3, the QR code for an S3 card, it'll take us here and it'll tell us what Amazon S3 is. It'll give us a different range of the price and 3 tiers. It'll also give us multiple use cases and then how it works. And this can come in very handy when playing some of the games that we had come up with at Hamilton Robson. It's also a great way to learn about any services you haven't heard of before. So here's a few snapshots of our team in action playing some of the custom games we've come up with. In the first image, you can see our placement student playing a game we call AWS Quick Draw. I'll dive into how that game works in the next slide. The next image shows our more advanced game, AWS Battle of the Architects, which really challenges us to think strategically about building AWS services. So let me start by explaining how to play AWS Quick Draw. So the rules of this game are we shuffle the deck. It's pretty simple. Shuffle the deck, each member draws a card randomly, and then whichever card they draw, they'll then do a 1-minute presentation on that service. We usually pick the cards in the morning, usually on Friday, and then present. The team have all day to sort of like get together the findings and then present it at the end of the day. And it's a great way for everyone to get involved and quickly learn a wide range of different services. So here we have Balaj, our placement student who participated in AWS Quick Draw. He's actually here in the front row. He's got the disguise on today. So Balaj drew the SNS card, a service he hadn't encountered before his placement. He went off, did some research, and then came back to present his findings to the team. In his 1-minute presentation, he covered what AWS or SNS is, some of its key features, common use cases, and then the benefits it offers. This not only helped him learn about the service that he hadn't heard of before, but also gave him confidence to present his findings to the group. And as you can see, AWS, it's a good way to quickly learn about an AWS service, but sometimes you want to take things up a notch and dive deeper into how these services can work together in a real-world architecture. And that leads us to our next game, AWS Battle of the Architects. This game is a bit more complex than Quick Draw, but it's incredibly valuable for learning how to architect real-world solutions using AWS. The goal of Battle of the Architects is to design the best architecture for a given technical spike. Players compete to receive the highest number of AWS well-architected cards by the end of 3 spikes, which ultimately determines the winner. And here's where it gets interesting. Sometimes you might have to justify a hacky solution, depending on what cards you've drawn, which adds an extra layer of strategic thinking. And at the end of the game, once the winner has been decided, we then come together as a team and run a retro, and this discuss what the ideal services and solutions would have been for the given spikes. This helps us reflect our decisions made during the game and get each other's approaches for that spike. So before we jump into this game, these are the rules that I've made. This is also a QR code that'll take you through those rules. Feel free to scan if you want. So before the game begins, we agree on a set of spikes. Sorry. And as you can see, we went for like a Spotify service. So the specs we've come up with is like store and access music files via an API, social sharing and collaborative playlists, and then subscription-based access control and rights management. Typically, we come up with around 6 of these different spikes. It's the add an element of surprise, and then once we've got the 6, we then turn the post-its around so they're all upside down, and then pick 3 randomly. This way, players can't plan too far ahead during the game, and then it ensures that each round for it to get the spike is fresh. So here's what a typical game scenario will look like. Players can see the 3 spikes until it's time for that specific round, keeping the element of surprise intact. Next, we have the well-architected cards that are used for the scoring of the game. And for each spike, the player can either receive 1 well-architected card, 2 1 well-architected cards, or 1 3 well-architected cards. And it's not just about using pure services, it's about creating a solid justification for your choices. If a player thinks they have a winning solution, they can call the challenge, explaining how their architecture best handles the given spike. This process adds a layer of strategy, making both the game educational and fun. This should make more sense when you see the gameplay flow. So during the playing phase, each player starts with 5 cards, and these are drawn from a shuffled deck, so you don't know what you're getting. As the game progresses, whenever a player draws a card, they'll pick 1 builder card, or 1 up from the builder card, and this ensures that they always have 5 builder cards to work with. There's 5 rounds within a given spike, and this gives players multiple opportunities to refine and build their architecture. An interesting strategic element is that players don't have to use all 5 cards, and this means they stand a chance to earn more points. So here's an example of the game in progress. Usually this game is played with more than 2 players, but just for demo purposes, we'll keep it simple with just the 2 players. So that player on the left here, and the player on the right. So as you can see, the player on the left has played an S3 card, and this is for the first spike. The next move for them would be to pick up one of the cards from the builder pile, and then the next player would then start to build out their architecture. So now that you can see, the player who placed the S3 bucket has also picked up from the builder card pile, and then they picked up this card, which is also the Amazon outfront card. And then player 2 has also dealt a AWS Lambda and as well, picked up from the builder card pile. So now as we move forward, you can see that each player has completed their architecture for this round spike. The next step is to determine the winner for this spike. So players will vote which architecture they think best fits that spike. And since both players used all 5 cards, the winner of this round will only receive 1 well-architected card. The voting process helps highlight the strengths of the different approaches for the same problem and offers a learning opportunity for everyone involved. As you can see here, the player on the left has won this round by receiving the well-architected card in the bottom left there. But remember, winning the spike doesn't mean that you've won the game. There's still 2 more spikes to be played. And with that, we'll reveal the next spike. So another 5 rounds are played by each player, and then the vote for the best architecture suited for the spike is carried out. In this image, you can see the architecture that has been voted for the best spike. And just to note, in this here, so with spike 1, it's also in play for the next 2 spikes. So you don't, for example, if we have like an Amazon DynamoDB, this doesn't have to be played again in the next spike, and it's still in play for the next 2 spikes. So let's have a look at spike 3 and how the game is actually completed. So here's the final architecture for spike 3. It highlighting the most innovative use of services. Now we need to determine the winner, and then we'll run a retro to discuss what the most ideal architecture would have been for each spike. We can determine the winner by saying he has the most well-architected cards. And as you can see here, the player on the left has 2 well-architected cards, while the player on the right only has the 1 well-architected card, which means the player on the left has won the game. So now we've determined our winner. Let's take a moment to reflect on what we've learned, and that's where our retro comes into play. So just to note, the real goal of the AWS BuilderCards isn't about winning. It's about deepening our understanding of AWS services and how to effectively design architectures. This exercise also helps us with reading architecture diagrams, but I'm sure you've seen quite a few today. And as we discussed earlier, even thinking about how to build out an architecture for a potential project. In this session, we discussed what the ideal services would have been for each spike. And when in the game, we were limited to the cards that we have in our hand. So using AWS BuilderCards offers some great benefits in learning AWS services as well as architecture. First, it makes the learning process more engaging. It turns what could be like a bit of a dry topic into something more fun and engaging. Secondly, it also encourages active learning, applying concepts rather than just reading about them. And it also fosters collaboration and teamwork. Players have to discuss their strategies and solutions. And finally, it's a bit of healthy competition. It pushes us to think critically and strive for the best architecture as possible. Before I wrap up, there's one more game that I would like to discuss. So it's essentially where the game idea came from. Using the gamified approach running the different AWS services through BuilderCards. The Hamilton Robson were big fans of Uno. So there was no way we'd introduce a game that involves cards without introducing a way of how to play Uno, which is what we've done. We found a few variations of how to play it with the builder cards. We even included the starter cards that I previously mentioned, we didn't really have a use case for. But you can, for the builder cards, you can play like a color on top of each other or plus the same name. But it doesn't really help you learn the different services when using the starter cards. So for the builder cards, you can play the same color on top of each other, or if a service directly works with another one. For example, you could play, if you have an API gateway was played, you could then play a lamp on top of it. Obviously, these are two different colors, but the services linked together. And then the well-architected cards are our pickup cards. So that is either pickup 1, it's not as harsh as doing pickup 2, or the pickup 3. But of course, these can be stacked, so you can end up picking up 6. So just to conclude, when there's some form of playing cards, there's always a way to play them. And that's it for me, folks. Thank you very much.